Hey pre-algebra kids, Mrs. Ginn here. I am going to videotape, while I still have access to the smartboard, the last few lessons of our book. So today we're going to do lesson 13 in unit 6, and this is called the Pythagorean Theorem. This theorem is one of my favorite theorems, and in order to go over it, you need to know what this shape is right up here. I'm sure you probably are familiar with the right triangle. But I'm just going to go over a couple of things to review before we move into the theorem. First of all, this is a right triangle because it has a 90-degree angle. And there's three different parts to it. There's two legs, and then there's the hypotenuse. So the long part is the hypotenuse, and the two legs that are shorter are legs. So this is the right triangle, and these are the things you're going to need to know as we move forward. Basically what we're going to be doing with the Pythagorean theorem is we're going to be finding the area of these squares. We know that area is equal to length times width. But we can also find area by counting these squares. So for example, if we were to find the area of the big square right here, we would basically go through and we would count. Notice that there's some half triangles or half squares down here, but we just would count most of all the squares. So if we count all the big ones, we got one here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So there's 24 big squares. These half squares, so two of them equal 1. That's 25. There's 2 here, that's 26. 2 here, that's 28. 2 here, 30. 2 here, that would be 32. 34, 36, and 38. Yes, 38. So we have a total of 38 squares for the big square. Now let's do the smaller ones. The smaller ones we can also kind of find by just counting the squares. So 1, 2, 3, 4, and then there's 4 going this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, oops, 9, 10, 11, 12, 13, 14, 16. So there's a total of 16. The other way that we can solve it though is we can do that length times width, and we know that it's 4 high and 4 long. So 4 times 4 is, well, what do we get? We get the area, which is 16, okay? So both of these are basically equal to 16. So this one equals 16, this one is 16. But in order to find that, we took 4 and we squared it. We took it times itself. So we have 4 squared plus 4 squared. Those we know both equal 16. Well, what is 16 plus 16? I'll give you a hint. It's 38. So in order to do the Pythagorean theorem, we take one length, which is 4, another length, which is 4. We square them both, and we get the other length squared. Because this is a square, we get this length right here squared. So 4 squared plus 4 squared, we know right now equals 38. So how do we solve for this length here, for this question mark? Okay, we know that it's going to be something squared, right? So we are going to do the opposite of squaring. We're going to take the square root of 38. So, because remember, we review a little bit, x squared is equal to the square root of, or x squared is equal to 49. In order to solve for x, we square both sides. Those cancel. We square 49. X is equal to 70, or 7. So what is the square root of 38? Well, that's a good question. I would have to use my calculator. But what I want you basically to get from this is that the Pythagorean theorem is a squared plus b squared equals c squared. All right? 4 squared plus 4 squared is equal to 38 squared. Or is equal to 38, because 16 plus 16 is equal to 38. If these were not equal to each other, the triangle would not be a right triangle, and we wouldn't be able to use this theorem. So I want to give you a couple examples to be able to solve for right triangles. Sometimes what you might get are an ordered pair that have 3 legs, A, B, C. So in order to test this theory, we can use our Pythagorean theorem, which is a squared plus b squared plus c squared, or equals, excuse me, not plus, it's equals c squared. So what we can do is we can square these, square all of them, set them equal to each other, and see what we could get. So 8 squared plus 15 squared should equal 17 squared. Well, 8 squared plus 15 squared, well, 8 squared is 64, and 15 squared is 225. 17 squared is 289. So does 289, because that's what we would get if we added those together, equal 289? Trick question. Yes, it does. So therefore, this guy right here is a right triangle. Why? Because it works. They equal each other. What about this guy? Let's do the same thing. So we're going to use our theorem. 5 squared plus 10 squared is equal to 12 squared. Let's see if it works. I know 5 squared is 25. I know 10 squared is 100. 12 squared, that combined is 125. That's easy. Okay, we'll just do that first. But 12 squared is what? 144. So does 125 equal 144? No. Therefore, it is not a right triangle. They're going to ask you to do this in your homework. You're going to get 3 ABC ordered pairs, and you're going to have to prove whether or not it is a right triangle or not a right triangle. When you do that, show your work, use your theorem, plug them in, and solve. If they equal each other, they are a right triangle. If they don't equal each other, then they're not a right triangle. This is how you show it, okay? One more example for homework sake or work time sake. They're going to give you a triangle with 2 legs, and they want you to solve for C. They want you to solve for the hypotenuse, okay? So in order to do this, we're going to use our same theorem, which is a squared plus b squared equals c squared. Now, I know what a and b are, so I can plug those in. A squared, well, we'll just do 30 squared plus 40 squared is equal to c squared. Okay, 30 squared is 360. No, it's 90. Let me make sure I'm on the right track for my math here. So 90, yes, it'll be 90. Because 3 squared, where's the 900? It's 900. 900, and then we have 40 squared, which 4 squared is 16, add 2 zeros. 1600 equals c squared. When we add these babies together, we get, well, I'll just do the longhand because it's good to do it. 6 plus 9 is 15. That, okay? That is equal to c squared. Now we're at a problem where, just like I had before, x is equal to 49. X squared is equal to 49. What do we have to do to both sides? Square root to find the answer. So we square root c, we square root 250 or 2500, and we get 50. C is 50. So this is another example of being able to solve for a certain length or hypotenuse. You could have 50 here and have to solve for 30 using this theorem. Lots of work to be shown, but this theorem right here, folks, is really what you need. So if you have a note card that you keep all the things you need to remember on, if you still have that at home, I suggest that you write this and you write something like PT for Pythagorean Theorem, or write a triangle, a right triangle above it so you remember it. A squared plus B squared equals C squared. Maybe if I get bored, I'll make a fun song about it. So this is how you do the Pythagorean Theorem. If there's any questions, we'll meet on Zoom. See ya.